I want to talk about one more problem. I don't think I'm going to totally finish it today, but I want to at least start to explore it. So where is it? Well, maybe we can finish this one. Let's talk about sublists. So I have a list, a vector, full of strings. In the example here, the strings are people's names. And I want to print out all of the possible subsets of this thing. It's like a power set, right? All the possible subsets of the vector. And I guess I shouldn't really say subset. I should say sublist, because I don't want to worry about duplicated elements and that kind of thing. So if the original list is Jane, Bob, Matt, Sarah, then that's, all of them is a sublist. And all of them without Sarah is a sublist. And just Jane and Matt, do you understand all the possible sublists, including some or all or none of these elements? That's what I want. And I don't care about the order. So like Jane, Matt is there, but I wouldn't also print Matt, Jane. I don't want that one. So that's what I want. OK? Now, if that's what I'm going to do, well, then here is a question. We're always thinking, what's the self-similarity? We're choosing, exploring, and unchoosing. What is the choice? What are we choosing? So here is a possible decision tree, call tree for this. So maybe what I'll do is available is all of the people. And I will try choosing Jane first. I will try choosing Bob first. I will try choosing Matt first. And then I will explore. If I chose Jane first, then maybe I'll try choosing Bob after her. Then maybe I'll try choosing Matt after her, and so on. This is possibly a decision tree you could use for this problem. But you see my little blue logo, right? So I claim this is not the right decision tree for this problem. And I want you to vote with me for a second. Let's do another one. I claim this is not the right decision tree. I want to know why it's not the right decision tree. Does it not find all the right subsets? Does it find them in the wrong order? Is it inefficient? Is it something else? What do you think? I think we framed the problem incorrectly here somehow. Go ahead and vote. I'll show the results in just a second. There's kind of a clear favorite answer among you guys, it looks like. And that seems to be the answer C, which is what? You guys think that it finds subsets, but it's inefficient. There's also a fairly sizable vote for A, which would be it doesn't actually find the subsets. OK, let me explain what I think is going on here. This decision tree is about order. It's about who goes first, Jane or Bob or Matt, and then who goes second, Bob or Matt or Sarah. This problem is not about ordering people. The last problem with permutations was about ordering people. That's not what's important about this problem. Let me show you the example output again. So I think we got one part of this right, which is that it seems like each call is dealing with one of these people, one person. That's the chunk of work, is a person. That's good. But what we did with each person was like put them first or put them second or put them third. If you really follow this tree to its logical conclusion, it'll just have all the 4 people. They'll just be in different orders. This is just a permutation tree. You know what I mean? What matters is not the order of the people. It's whether or not they are included in the set. It's inclusion versus exclusion. What's the difference between the left column here and the right column? Jane. All of the ones on the left have Jane in them, and all of the ones on the right have Jane missing. They're the same otherwise. Do you see that? That's the decision to be made. Is Jane in or is she out? Not is she first, second, third, or fourth. Swipe left, swipe right. Do you like Jane or not? Ah, come on. This is a better decision tree, I claim. You start out with everybody available and you've chosen nothing. The decision tree does not split in 4 for each of the 4 people. No, it doesn't do that. It splits in 2 because my call is going to handle the first person. Jane, what am I going to do? I will decide, do I keep her or do I not keep her? That's the decision. Those are the 2 options for the decision, yes or no. The next decision is when I look at the second person. Do I keep him or do I throw him out? So the code you end up writing is not looping over each person and trying to put them first and trying to put them second. That's not what you end up writing. The code you end up writing is more like this. And I want to just talk about this code because we don't have enough time to write it yet, but we'll explore more. The idea is if there's nobody to pick, you print who you've chosen. We're doing the same business about a vector of who we've chosen and so on. That's fine. So if there's nobody to choose, print who we've chosen. But what we're going to do is not loop over all the people. We're going to only look at the first person. Pull the first person out of the vector. Remove them. That's Jane. Pull her out. She's not in the vector anymore. There's 3 people left in the vector, and I've got the 4th one as a string, as string first. Okay? Now, the choices are to either include her by putting her in the chosen vector, or to not include her. And both of those cases, I do a subcall. And if you think about it, this one will get down to the bottom where the vector is big, and I print, and Jane is in the vector. And this one will get down to the bottom where there is no Jane, and I print the vector without her. And so this code, I like this example because it feels like that permutation one, and you're tempted to loop over and pick int I, pick the element I, put them first or whatever. But that's not what the problem is actually about. So it's really important for each problem like this to really figure out what you're choosing for each unit of work, what each function call's responsibility is. We were right that it was to handle one person, but not where they went in the vector, but whether they went in the vector. And that's a 2-way split. So there's no loop here. Each call leads to 2 more calls. One call with the person and one call without the person. That's why this code ends up looking like this.